Hi everyone, so now we're going to go over fractional exponents. This is new stuff, so don't feel like it's a review again. So the big thing on here is that when we have exponents, we can convert them to radical form and vice versa. If we have radical form, we can convert it to exponential form. And the formula for it is written down right here. So a to the power of m over n is equal to the nth root of a to the m. So basically you just take the denominator of the exponent and you shove it over to be right in front of the square root sign, which just makes it the nth root. So we'll use this in a couple of these examples, but the first example we have is just a simplification one with fractions. So it's 36x to the 8th to the power of 1/2. So from the last video, you should recognize that this is a power rule, which means I'm going to distribute that 1/2 in. It's going to be 36 to the power of 1/2 and x to the power of 8 times 1/2. So 36 to the power of 1/2, you can plug that into a calculator, but the cool news is this is the same thing as saying the square root of 36. So something to the power of 1/2 is the same thing as square rooting it. We know that the square root of 36 is 6, so 36 to the power of 1/2 is 6. And then for your x, you have x to the power of 8 times 1/2. Well, 8 times 1/2 is 4, so my final answer is 6x to the 4th. All right, so that was my simplification one. Now we're going to start using this formula, which again you have written down on your key term sheet. So for the second example, we have 2x to the power of 7 over 4. So like this says up here, what I'm going to do is take that denominator, which is 4 in this case, and wrap it around to go inside the root to make it a 4th root like this. And then we keep the 2x inside parentheses, and that's just now to the power of 7 because that 4 wrapped around. And that's my final answer. I'm done. That's my radical form, what we wanted. Okay, so now let's look at the next example. The next example is a little bit trickier. It is 7x to the power of negative 4/3. If you remember, we don't like negative exponents, right? So the first thing I'm going to do is get rid of this negative exponent by shoving it to the bottom of a fraction. I can rewrite it as 1 over 7x to the power of positive 4/3. Now that I have that positive exponent, I can do the same thing where I take the denominator, which is 3 in this case, of the exponent, wrap it around to make it the root, and it turns into the cube root of 7x to the 4th power. And notice that it's still under 1, so you have to keep it in the fraction, but this is our final answer. All right, now let's look at that last example, which is the opposite. So now instead of going into the rational form or the square root form, we're going to take it from the rational form to the exponential form. So it's basically the opposite. We're going to take the number that's inside the root and wrap it around so that it becomes the denominator of the exponent. So, and when we do this, we want to take everything that's inside the square root and put it in parentheses. So 6x will go inside of parentheses, and then we're going to have 3 to the power, or 3 over 5, because that 5 right there wraps around and becomes the denominator. And this is our final answer. Two really small things. If I don't have a number, like a number right here in that root, there's a little imaginary 2 right there. So we would wrap around a 2. And then if I don't have an exponent right here, then it's a 1. It's a little imaginary 1. So for example, if I have like the square root of x, I can change that because there's a little imaginary 2 right here and a little imaginary 1 right here. That would be the same thing as x to the power of 1/2. And there we go. That's how to convert between exponential and radical forms.